Let's jump into it. Our complex numbers, or the complex plane. Well, that's going to be for 4.3. I think before we get to that, why don't we go through and just do a quick refresher as to what the heck are complex numbers or imaginary numbers. So let's hop into it. Let's start with the imaginary numbers. The imaginary numbers. Imaginary. And it all starts off with this, right? We've seen it. I is equal to the square root of -1. Well, we probably got that in some sort of algebra class when doing the quadratic formula or something like that. We end up with our imaginary part. Well, that's what an imaginary number is. It starts off with this, that I is equal to the square root of -1. Starts off with just this basic idea that x squared plus 1 is equal to 0. X squared is equal to -1, and then x is equal to plus or minus the square root of -1. There's no solution to this in the real numbers. But somebody back in the day went, you know what, let's come up with some new number system. We're going to call it the complex number system. And in the complex number system, we're going to use imaginary numbers. Oh, let me show you. I'm going to give you the idea of what a complex number is. So complex, and it's of this form. A lot of times we call it Z, but I'm just going to write it out as A plus B times I. And that's a complex number. And we're going to mess around with these complex numbers. So I'm just going to give you some examples. Just a few different little examples as to how the complex numbers might look like. So examples. Here's some. 2 plus 3 times I. All right. So this is a number. We have our, what we call our real portion, right? The real number. And then we're going to call this our imaginary portion. Okay, right, because it's attached to the I. So we have imaginary numbers inside the complex numbers. Okay, let's do a couple more. Let me do this one. Let's do -7 minus 1/3 I. All right, we got a real portion and an imaginary portion. Here's another one. We're just going to keep going. Oops. 8. There's a complex number where we're saying that A is equal to 8 and B is equal to not a dang thing, plus 0 I's. They're saying there's no imaginary portion. So the number 8 is actually part of the complex number system. The number 8, so is 1,000,000. Every real number is in the complex number system, plus more. It's a bigger number system. So let's do another one. Let's switch to one. So, of course, we could have 3 minus 6i. There's another one. How about just this? 7i. Right? And what we're saying here is there's the imaginary portion where our b is equal to 7, but our a is equal to 0. All right, so it's like this. 0 minus 7i. Or plus, sorry. Minus. All right. So that's kind of the game. There's our complex numbers. And we're going to need to be able to multiply these together, add them together, and such. So let's just get into a few more examples. I know I'm just throwing stuff at you real quick. It is a prereq of the course, and we're going to get our practice through our homework anyway. If you don't remember, you will soon. So let's do a little something like this. Let's take 4 plus 3i. And let's take it and we'll add it to, let's go with -1 plus 2i. And imaginary numbers work out, or the complex number system works out nicely. What we're going to do is we're going to keep all the real portion together, and we're going to keep all the imaginary portion together. Because remember that when we have a number, it's written as a plus bi. We always throw the imaginary portion at the end, and we keep the real portion at the beginning. So what we're going to do is we're going to say that when we add these two together, we go, well, what's 4 times -1? And that's negative, or 4 times negative 1. Gosh darn it. What's 4 plus negative 1? And that's going to be 3, right? 4 plus negative 1. We put those two together. And now we go, hey, if you have 3 i's, and then you give me 2 more i's, I have 5 of those i's, and there it works. And that's how we will do any sort of addition. Well, what if we had 4 plus 3i, and now we subtracted out negative 1 plus 2i, that other one. So using the same 2, we're going to keep the real portion with the real portion, the imaginary portion with the imaginary portion, and then we're going to do a little bit of addition or subtraction. So 4 minus negative 1, 4 minus negative 1, I think we're going to add the 1. And then we're going to have 3i minus 2i, and that's just going to leave us with 1i. And there we be. So this is how we would add or subtract complex numbers. All right, that's not that big of a deal. It just keeps the reals with the reals, the imaginaries with the imaginaries. But we're also going to need to know how to multiply these together. And in order for us to know how to be able to multiply these together, we need to talk a little bit about I. I is equal to the square root of negative 1. Jumping right back to it, I is equal to the square root of negative 1, but we need to talk about what happens when you square it, when you multiply it together. So the square root of negative 1 times the square root of negative 1 is just equal to negative 1. Now this can continue down, it actually forms a pattern, but really this is where I want our attention to. I squared is equal to negative 1, and I is equal to the square root of negative 1. Really, the second one's going to be what we use most. We start treating I just as it is what it is. So why don't we do a little bit of a multiplication by using this concept here. Let's take 2 plus I, and we're going to multiply it with, let's go with negative 3 plus I. Okay. Now it's going to work the same way when we multiply together that we would just doing any sort of algebraic. We're going to FOIL, first, outer, inner, and last. We'll take it and be like, all right, so 2 times negative 3 is negative 6. And then we're like, 2 times I would be like 2 times I. And now we'll do our inner, and we'll say I times negative 3, that's negative 3i. And then lastly, we're going to have I times I. And that's going to become I squared. Do you see how this might become useful now with that I squared? That's going to turn into a real number. So let's clean that up, and we're like, well, wait a second. We got negative 6 plus 2i. I'm going to rewrite it, I know. And we're going to say instead of plus I squared, we're going to just replace it and say this is going to be negative 1. Now we put it all together. We've created ourselves a new complex number. Negative 6 minus 1 is negative 7, and 2 i's, remove 3 i's, will get you a negative I. And that's how we're going to do any sort of multiplications. It'll be any sort of multiplication. So by using foiling and letting it just run all the way out. All right, lastly, the last thing I really want to start talking about before we jump into it. Maybe I'll get you another one. Maybe I'll do one on polynomials, but I don't know. We'll see and plan this by ear. Let's talk about the idea of a conjugate. Jeez, come on, learn to spell, dude. You know, conjugate. This looks terrible. Oh, that's better. Okay, I give you this. 4 minus 3i. What's its conjugate? Its conjugate is 4 plus 3i. Okay. 7 minus the square root of x. What's the conjugate? 7 plus the square root of x. Negative 7 minus 2 plus 2i. Its conjugate? Negative 7 minus 2i. 8. What's its conjugate? 8. Right? 8 plus 0i's is still the same thing as 8 minus 0i's. You know what I mean? And it's got to do it. Negative 4i. What's the conjugate of negative 4i? Positive 4i, right? Because there'd be 0 in front of this thing. Plus, plus. We don't write any of that crap. Okay? So there's the idea of conjugates. But conjugates are dope because when you put them together and you multiply, you will remove all the i's. All the i's will go away whenever you multiply something by its conjugate. I'm going to give you the example right up here. We'll say 4 minus 3i times 4 plus 3i. And let's just multiply 1 through. If you're going on to calculus, you're going to use this trick like crazy. So let's bring the 4's through. We get 16. 4 times 3i would be 12i. Now let's do our inner. Negative 3i times 4 is going to be negative 12i. Oh, look at that center, how it's going to cancel right out. And then we're going to be left with negative 3i times positive 3i. That's going to be negative 9i squared. Let me see in the center. That just cancels right away. We're going to get 16. And let's write the minus 9. And then instead of writing I squared, let's write what it equals. Negative 1. So this became 16 plus 9, which is going to get us, what's 16 plus 9? I can never seem to remember. Oh, yeah, that's 25. It's like a 3, 4, 5 triangle or something. Weird. So that's how we're going to mess around with those conjugates. It gets rid of all of the imaginary numbers, and that's good news at times. So here's your lead in. Sorry if it was a little just jumbled. I just wanted to get you a lot of information real quick in case you had forgotten, because we're just hopping right into the complex plane. So I don't think I'm going to get you another video. I think we're just jumping right in. We're going to go for it. So I will see you in the next.